Alright guys, so after that little introduction, we're ready to move on to some continuous random variable distributions. Okay, the first one we're going to look at is continuous uniform random variables. Now I don't believe this is given to you in the formula packet, but it is pretty easy to kind of set up and derive from the beginning. Okay, so we're looking at a continuous uniform random variable, which means that the function, our f of x, is constant. So if we kind of think about this over here, we did this for discrete random variables. Remember, we did x as a du n, and n was just the number of steps that we needed, and so the probability distribution function was just 1 over n. That was also the probability of each specific event occurring. This one's going to be a little bit different. It is going to be a constant, so it's just a horizontal line. So that's our f of x. Now we want to go from a to b, because it's not a specific number of units, it's a full range that we need to be able to look at. And so again, we want our probability distribution function, which is all this right here, we want our PDF to add up to 1. So if that's the case, then 1 needs to equal the length of my base, which is b minus a, and then times the height, which is whatever that constant was, so f of x. And you can see right here it's fairly easy to then say that f of x equals 1 over b minus a. Okay, so we now have a formula for the constant for a continuous uniform random variable. Alright, so now let's say what I would like for us to do, this is now represented without not with a d, because it's not discrete uniform, it's just uniform, and it goes from a to b, because that's going to be important how big our range is, right? N represented the number of steps. Now that I have an infinite number of steps, I just need to know how far that goes from a to b. So the first thing that we're going to look at is we're going to try to come up with a formula for the expected value. Alright, so let's just start with the expected value, ex, and we know that the ex is equal to the integral from a to b of x f of x dx. Right, that's been what we've been using for the last unit. We were using the sigma, but now we're going to use the integral to be able to get the expected value. And so with that, we now go the integral from a to b of x, and f of x being a constant is 1 over b minus a. And it is important that we recognize that's a constant, because now we're going to pull it out. So we're going to have 1 over b minus a, and then integrate the x, because that's the only thing left. So it will be 1/2 x squared from a to b. And so I've done the integral, so the dx is gone, the integral is gone. I'm just left with evaluating from a to b, which then leaves me, and some of you are probably starting to see where this is headed. So this will be 1/2 times b squared minus a squared. And of course, b squared minus a squared will factor. This all goes up on the top. So in the end, b squared minus a squared will be b plus a, b minus a, all over b minus a, and then I've got the 1/2 there, so 1 over 2. You'll notice that the b minus a's cross out, leaving us with the expected value for a continuous uniform variable as being b plus a over 2. Alright, so we've got the expected value now, which is fairly straightforward, which makes sense that the expected value should be right in between the two if it's continuous. Alright, so that's something we could have reasoned out, but we were also able to kind of prove it. Let's look at the variance. Okay, so for variance of x, then we're just going to do the expected value of x squared minus mu squared. Okay, so for the expected value, we're going to do the same thing as over here. So we're going to go the integral from a to b, and we already know that the expected value is b plus a over 2. What would happen if I squared this? Well, it would just be this squared right here. So that means it's just going to be x, instead of x, I'm doing the expected value of x squared. F of x is still b minus a, but right here, instead of x, I'm now doing, instead of x, I'm doing x squared. So it'll be x squared over b minus a dx, of course, and then minus mu squared. Now from here, again, b minus a is a constant, so I can pull out the 1 over b minus a. Integral from a to b of x squared dx. And the mu, of course, is just the expected value, which I already have. So that one I do have. The other one, expected value of x squared, I didn't have, so I had to find that one out. So I've got b plus a over 2 squared. And from here I can take the integral, so that's going to leave me with 1 over b minus a, and then 1/3 x cubed evaluated from a to b, and then minus this whole thing, which I'm going to start expanding that. So I'm going to have b squared plus 2ab plus a squared all over 4, because I've got to square the top and the bottom. Okay, if I want, I can leave it in parentheses, but I know that minus needs to go to everything. This is going to, of course, become one single fraction. I'll have the 3 on the bottom from the 1/3. I'll have the b minus a on the bottom from that one. And then on top, I'm going to have x to the 3rd, which will be b cubed minus a cubed. Okay, I factored out the 1/3 because it's a constant. And then that will go down here on the bottom. And I still got the same minus b squared plus 2ab plus a squared over 4. B cubed minus a cubed. Hopefully you remember your difference of cubes, but if not, that's equal to b minus a, b squared plus ab plus a squared, just like that. Notice that there's a b minus a, which will cancel out, leaving me then with, on the top, b squared plus ab plus a squared all over 3 minus b squared plus 2ab plus a squared all over 4. When I put those together, I do need a common denominator of 12, so it will be 4b squared plus 4ab plus 4a squared minus, now this one I'll multiply by 3, so 3b squared minus 6ab minus 3a squared all over 12. I put those together. Notice I got 4b squared minus 3b squared, which will give me b squared. 4ab minus 6ab, which would be minus 2ab. And then I got 4a squared minus 3a squared, which will be plus a squared, which, strangely enough, factors to b minus a squared over 12. And so my variance then is b minus a squared over 12. This is for any, remember we're doing a general statement here, so this is for any continuous uniform random variable. All right, so hopefully that makes sense. Hopefully that leads you to understand kind of what's going on, the formulas that we can use for discrete random for continuous uniform random variables. I think with this you should be able to answer any questions that come up. So use these, and hopefully that's enough to kind of get you started.